I want you to imagine a very specific scenario. Picture yourself sitting out on a patio or a back deck.
Hmm.
It's dusk. The air is finally starting to cool down after a long, blistering summer day.
Yeah.
You're just settling into a chair. Maybe you have a cool drink in your hand. You're watching those stars come out. And suddenly, completely out of nowhere, you are hit with it.
Oh, yeah.
The most intoxicating, rich, overwhelmingly sweet, floral scent you could possibly imagine. And it doesn't just waft past you. It completely envelops the space.
It really does.
But here's the truly wild part about this scenario. You look around your immediate area. You check the potted plants next to your chair. You look at the garden beds nearby. And you can't even see the plant this perfume is coming from.
Right, because it's nowhere near you.
Exactly.
Right.
Because the source of this incredible fragrance can actually project its scent up to a staggering 300 to 500 feet away.
It's an absolute marvel of the botanical world. I mean, when you think about the physics of scent dispersion, a fragrance that powerful, capable of traveling the length of a football field and a half on a gentle evening breeze.
It's crazy.
It is, originating from a single stationary organism. It's an evolutionary triumph. Very few plants on Earth possess that kind of aromatic horsepower.
That aromatic horsepower belongs to the legendary Night Blooming Jasmine, which is widely renowned in horticultural circles as the strongest smelling plant globally.
Oh, absolutely. People design entire backyard landscapes around the promise of that evening perfume.
They really do. But when I was compiling the botanical research, the horticultural guides and the grower notes for our discussion today,
Yeah.
I stumbled onto a detail that completely changes how we have to look at this plant.
The big twist.
The big twist. This famous jasmine that people obsess over, that they plant near their bedroom windows, is living a complete double life. It's fundamentally living a lie. It is not actually a jasmine at all.
Not even remotely. If you trace its genetic lineage, it sits on a completely different branch of the evolutionary tree from the true jasmines we typically associate with that classic floral scent.
Yeah.
It's a brilliant deception, masked by a misleading common name and a convincing aromatic profile.
When I pulled up the actual taxonomy, I had to read the family classification 3 times just to make sure I had the right plant.
Yeah.
Because the genetic reality is that this beautiful, sweet-smelling floral vine belongs to the exact same botanical family as tomatoes, bell peppers, potatoes,
Deadly nightshade.
deadly nightshade.
Yep. The Solanaceae family. It's a revelation that usually stops gardeners right in their tracks.
I mean, I was stopped in my tracks.
You go to the nursery, you bring this beautiful plant into your home or your yard, envisioning a delicate, romantic floral experience, and without realizing it, you are actively cultivating a member of the nightshade family.
Right.
A family notorious for producing some of the most potent chemical compounds, both edible and legal, in the natural world.
And that stark contrast between the romantic expectation and the botanical reality is exactly why we're dedicating our entire deep dive today to unpacking this plant.
It deserves it.
We're going to provide the ultimate comprehensive masterclass on the organism scientifically known as Cestrum nocturnum.
We are going to map out its entire existence. That means exploring its true botanical identity, dissecting the evolutionary brilliance of its nocturnal behavior, and critically breaking down exactly how to manage the intense, very real toxicity that comes hand in hand with its nightshade heritage.
And we're taking this far beyond just the theoretical science. We're going to walk you through the precise, step-by-step horticultural protocols required to make this plant thrive in your specific environment.
Whether you're keeping it indoors as a houseplant or putting it in the ground outside.
Exactly. We'll examine the exact soil mechanics it demands, the specific art of watering it without drowning the root system, the strict pruning schedule you have to follow to force it to produce those incredible blooms, and even a masterclass on how to propagate it from stem cuttings so you can create infinite clones.
By the end of this conversation, you are going to possess the knowledge to become a master cultivator of the Queen of the Night.
So let's jump in. It's an organism that demands a very high level of respect, but when you meet its specific needs, it rewards you with a sensory experience that is practically unmatched in the garden.
I think a fascinating entry point into this discussion is looking at how this plant has managed to capture the human imagination for centuries, completely transcending its rather dark botanical lineage. There's a piece of literature from the Irish poet Thomas Moore that I found in the historical notes we compiled, and it perfectly encapsulates the drama and the mystery of this plant. He wrote, "From plants that wake when others sleep, from timid jasmine buds that keep their odor to themselves all day. But when the sunlight dies away, let the delicious secret out to every breeze that roams about.
Let the delicious secret out. That's such a vivid way to describe the transition. But I want to pause and untangle the identity crisis we touched on earlier.
Sure.
If this plant is a nightshade, how did it end up with the name jasmine plastered all over it in the first place? It feels like a massive failure of categorization.
Well, it's a perfect example of the inherent limitations and, frankly, the dangers of relying on common names in botany. Historically, the term jasmine or jessamine was not used as a strict scientific classification.
Right, it was just a loose descriptor.
Exactly. It was tossed around as a generic descriptor applied to dozens of completely unrelated plant species all over the globe simply because they shared two superficial traits. They produced highly fragrant flowers, and those flowers were usually white or light-colored.
Makes sense why they grouped them together back then, but it's scientifically a mess.
It is. True jasmines, the plants that actually own that name scientifically, belong to the Jasminum genus. These are the plants you might be familiar with if you have ever grown winter jasmine, pink jasmine, or royal jasmine.
And if we look at the family tree for those true jasmines, they're actually in the olive family. They're essentially cousins of the olive tree.
Precisely. They are entirely unrelated to the nightshades. But our subject, the Night Blooming Jasmine, is officially categorized as a jessamine with an E in many older texts, which is a nod to that loose historical naming convention.
Its true scientific identifier being Cestrum nocturnum.
Right.
Yeah.
It's a tropical evergreen shrub that naturally originates from the warm, humid regions of the Caribbean and the West Indies.
What strikes me about its physical appearance is how brilliantly it plays the role of a completely average, forgettable plant during the daytime.
Oh, it really does.
If you were to just walk past a Cestrum nocturnum at noon, you probably wouldn't even turn your head to look at it twice. It seems almost intentionally unassuming.
It is the definition of unremarkable under the sunlight. It possesses a moderately fast growth rate and develops what we call a vining or arching habit. The branches tend to sweep upward and then gracefully bend back down under their own weight.
And the leaves are just basic leaves.
Simple, pointed, glossy, dark green leaves. Now, it can grow to be quite massive. If left unchecked in an ideal outdoor environment, it easily reaches up to 10 feet tall and 6 feet wide.
Wow.
Because of that dense, arching growth, it makes for a fantastic structural privacy hedge or a dense screen. But if you look closely at the flowers during the day, they are incredibly underwhelming.
They just look like little green matchsticks.
Exactly. Tiny, slender, tubular, creamy white or pale green structures. And during the daylight hours, they are tightly sealed shut, clinging to the stems.
They're essentially on standby, hiding all of their biological potential. But then the environment shifts. The sun dips below the horizon, the temperature drops slightly, and the night shift begins.
This transition is where the profound evolutionary brilliance of Cestrum nocturnum is revealed. Those tiny matchstick-like tubular flowers operate on a strict biological clock.
They know exactly when to open.
They open exclusively at night and close themselves back up the moment the sun begins to rise. And the instant those petals peel back in the dark, they release that overpowering, sweet, intoxicating perfume we talked about.
Which raises a massive ecological question. Why would a plant evolve to ignore the sun entirely?
It's a great question.
The vast majority of the flowering world is putting on this massive, colorful, aromatic display during the day to attract bees, butterflies, and hummingbirds. Why would this specific nightshade choose to sleep through the busiest biological hours of the day?
To understand that, we have to look at the garden not just as a collection of pretty plants, but as an incredibly fierce, highly competitive biological marketplace.
It's a war zone out there.
It really is. During the day, the competition for the attention of pollinators is brutal. You have millions of flowers competing for a limited number of bees and daytime butterflies. The environment is loud, both visually with bright colors and chemically with a chaotic mixture of scents.
So it just bows out.
Exactly. By waiting until darkness falls, the Night Blooming Jasmine effectively steps completely out of that crowded arena. It has adapted its biological clock and the physical structure of its flowers to attract a completely different, highly specialized workforce, nocturnal pollinators.
So we are talking about creatures that navigate in the dark, moths and bats.
Specifically moths, certain species of bats, and a few specialized night-feeding birds.
Wow.
Every aspect of the flower is engineered for them. The tubular shape we mentioned, that is not an accident. It is perfectly deep and narrow to accommodate the long, specialized proboscis of a moth hovering in the dark. The pale green or creamy white color of the flower might seem dull during the day, but at night, under the moonlight, those light colors are highly reflective.
They act like glowing landing pads against the dark green foliage.
Exactly. And the intense fragrance, that 300-foot scent radius, serves as a potent chemical beacon, cutting straight through the darkness to summon pollinators from massive distances. It's a highly specialized, incredibly efficient reproductive strategy that bypasses daytime competition entirely.
The mechanics of that are just staggering. But as I was reading through the ecological notes, I found a fascinating side effect of this intense chemical beacon.
The mosquito repellent aspect.
Yes, while the plant is busy pumping out this perfume to summon moths and bats, it famously provides a massive, very practical perk for us humans.
It acts as a highly effective, completely natural insect repellent, particularly targeting the pests that ruin a summer evening.
The specific chemical compounds embedded in that intense fragrance, the very same molecules that are irresistible to a moth, appear to be highly attractive to mosquitoes.
If you think about the utility of that, it makes this the ultimate patio specimen. You plant this near your seating area, you get a lush privacy hedge that can grow 10 feet tall. It completely transforms the atmosphere of your evenings with a fragrance that smells like absolute paradise. And simultaneously, it acts as a biological shield against mosquitoes while you're just trying to sit outside and enjoy the night.
It's a remarkable set of traits for a single plant to possess. However, this convergence of the beautiful fragrance and the utilitarian pest control brings us to the critical pivot in our analysis.
We have to talk about the toxicity.
We do, because we can't ignore its taxonomy. Because it's deeply rooted in the nightshade family, this plant harbors a hidden dark side that requires immense respect and careful management.
It really does.
If you're going to bring a Cestrum nocturnum into your living space or your yard, you have to fully understand the biochemical risks involved.
Let's shine a bright light on that dark side. We established that it is a cousin to deadly nightshade. That is not just a quirky piece of trivia. It translates to a very real, very potent toxicity.
And the toxicity is systemic. It's present in every single physical part of the plant.
Every part. The intricate root system beneath the soil, the vining stems, the glossy green leaves, the fragrant flowers themselves, and most critically, the clusters of small, fleshy white berries that develop after the blooming cycle concludes.
Every one of these components is highly toxic to mammalian biology. That category includes humans, naturally, but it poses a particularly high risk to domestic pets like cats and dogs, as well as livestock, specifically horses.
I want to translate that from botanical warning labels into practical reality. This is not a plant you can casually place on a low coffee table if you have a curious golden retriever puppy that likes to chew on sticks.
Or a toddler who is in that developmental stage where they explore the world by putting absolutely everything they find into their mouth.
Exactly.
What exactly is happening on a chemical level that makes this plant so dangerous?
Well, the danger stems from the plant's production of powerful alkaloids, specifically solanine and various atropine-like compounds. To understand how these work, think of an alkaloid as a highly sophisticated chemical defense mechanism designed by the plant to deter herbivores from eating it.
It's chemical warfare.
It really is. Solanine, for instance, is a glycoalkaloid poison common across many nightshade species. If a mammal ingests any part of the Cestrum nocturnum, these toxic compounds enter the bloodstream and immediately launch a dual attack on the nervous system and the gastrointestinal tract.
The clinical symptom list provided in the veterinary and botanical safety sources we reviewed is not just a mild stomachache, it's genuinely alarming. The body's response is violent.
Very violent. The initial physical reactions are severe. An exposed animal or human will experience a rapid spike in body temperature, accompanied by a highly accelerated erratic pulse. You'll see excessive, uncontrollable salivation.
And then the stomach issues start.
Right. This is quickly followed by acute gastritis, which manifests as intense, painful stomach cramping, violent vomiting, and severe diarrhea as the body desperately attempts to purge the toxins.
And if the dose is high enough, or the initial symptoms are ignored, the toxins begin to systematically shut down the neurological and neuromuscular pathways.
The progression is frightening. It leads to profound muscle weakness, eventually cascading into partial or full paralysis. It suppresses the respiratory system, leading to breathing failure. On a neurological level, the atropine-like compounds can induce severe delirium, hallucinations, and ultimately violent seizures.
There are even documented reports suggesting that simply being enclosed in a small, poorly ventilated room with a massive, heavily blooming Cestrum nocturnum can cause intense headaches, nausea, dizziness, and respiratory irritation in highly sensitive individuals just from inhaling the concentrated volatile organic compounds.
Though, to be clear, the primary life-threatening danger always comes from physical ingestion.
Definitely. So we need to outline clear, actionable safety protocols for you. If you're choosing to grow this plant outdoors in your garden, placement is your first line of defense.
You must position it strategically, far away from areas where your pets roam unsupervised and absolutely out of reach of any grazing livestock.
And if you decide to cultivate it indoors as a houseplant, which is a very common and highly rewarding practice, the management becomes much more hands-on.
Very hands-on.
The horticultural guides are unanimous on this point. The moment you see those small white berries beginning to form after the flowers fade, you must intervene. You take your pruners and you cut them off immediately.
Do not allow them to mature, and under no circumstances can you let them drop onto the floor where a cat or dog might mistake them for a toy or a piece of food.
That proactive pruning is essential. And if the worst happens, if you suspect your pet has taken even a minor exploratory bite of a leaf or a dropped flower, you don't wait around to monitor their symptoms. You act immediately.
Gently wash their mouth out with water to remove any lingering plant debris. Keep the animal as calm as possible to prevent their heart rate from spiking further, and transport them to an emergency veterinarian clinic immediately. These specific nightshade alkaloids metabolize and act incredibly quickly.
This intense toxicity profile brings up a highly stressful dilemma for anyone who loves plants and loves their pets. The retail plant market is a confusing, often poorly labeled landscape. We mentioned earlier how the common name jasmine is slapped onto dozens of unrelated plants.
The jasmine roulette.
Yes. Playing jasmine roulette at the garden center can have catastrophic consequences if you don't know exactly what you are buying.
It's a massive vulnerability for consumers. You can walk into a big box nursery right now and you will likely see 5 completely different plant species, all sitting on the same display table, all carrying a plastic tag that prominently features the word jasmine.
And they all look vaguely similar to a beginner.
Exactly. If you do not possess the knowledge to check the scientific Latin names printed in the fine print on the back of those tags, you are effectively flying blind. You have no idea if you are purchasing a harmless floral vine or bringing a highly toxic biological hazard into your living room.
We need to clearly map out the landscape of these different jasmines so people know how to navigate the nursery safely. Let's start with the safe harbor. The plants you can confidently purchase and bring home without having a panic attack every time your cat walks past the pot.
The undisputed champion of the safe indoor jasmine category is star jasmine. If you look at the tag, you want to see the scientific name Trachelospermum jasminoides.
That's a great one.
It's a beautiful plant. It produces highly fragrant, star-shaped white flowers. It is excellent for attracting beneficial pollinators to a balcony, and most importantly, it is entirely non-toxic to cats, dogs, and humans.
Another superb, completely safe option is the Madagascar jasmine. Its botanical name is Stephanotis floribunda. You can identify it by its thick, leathery, dark green oval leaves and its clusters of soft, tubular white flowers.
It's actually a classic choice for bridal bouquets because of its scent and longevity. It poses zero toxic threat.
Checking the safety index in our sources, they also highlight orange jasmine, Brazilian jasmine, and Chilean jasmine as generally safe bets for a household with pets. There is a minor caveat noted that if a dog were to consume a massive, unnatural quantity of the Brazilian or Chilean varieties, it might trigger some mild indigestion or an upset stomach.
But they contain absolutely nothing lethal or neurologically damaging.
Right. Those species represent your safe zone. But now we have to examine the imposters that occupy the danger zone. Aside from our primary focus today, the night blooming jasmine, there are several other plants masquerading under the jasmine moniker that pose severe, sometimes life-threatening risks to mammals.
First on the imposter danger list is the Cape jasmine. If you look at the scientific tag, it will read Gardenia jasminoides.
And the name is a complete misdirection.
It is. This plant is not a jasmine at all. It is actually a species of gardenia, which places it squarely in the coffee plant family. The danger here lies in its chemical makeup. It contains potent compounds known as geniposide and garnicide.
If a cat or a dog chews on the thick, glossy leaves of this plant, those compounds trigger a severe, acute gastrointestinal reaction. It causes profound stomach cramping, vomiting, and overall systemic illness.
Then we have a plant commonly sold as crepe jasmine, mathematically known as Tabernae montana divaricata. You might also see it marketed under the name pinwheel flower.
This specific imposter is highly dangerous.
Extremely. The Tabernae montana genus produces a complex cocktail of alkaloids. If ingested, these chemicals don't just upset the stomach, they attack the nervous system, causing delirium and partial paralysis. Furthermore, they are known to induce cardiotoxicity.
Meaning the alkaloids directly interfere with the electrical signals and muscle tissue of the heart, leading to dangerous arrhythmias.
Correct. But the final plant on the imposter list is perhaps the most terrifying one to accidentally bring home. The Carolina jasmine, scientifically classified as Gelsemium sempervirens.
Also frequently sold as yellow jasmine.
Yes. This plant requires extreme caution. The toxins present in Gelsemium sempervirens are fast-acting and highly potent. Ingestion can be completely lethal within a matter of hours.
The chemical compounds cause profound, rapid muscle weakness that escalates into full paralysis. It triggers severe hypothermia, dropping the body temperature to dangerous levels. It attacks the optic nerve, causing acute vision problems and blindness, and ultimately leads to complete respiratory failure as the muscles required for breathing stop functioning.
The ultimate lesson here, the unshakable rule for navigating a plant nursery, is to never ever place your trust in a common name printed in big letters on a plastic tag.
Do not buy a plant simply because it says jasmine.
Take out your smartphone, look up the scientific Latin name printed on the barcode sticker, cross-reference its toxicity, and know with absolute certainty what kind of biological entity you are bringing into your home ecosystem.
Armed with that knowledge, once you have positively identified your Cestrum nocturnum, and you have made the conscious decision that you can safely and responsibly manage its toxic nightshade properties, the next major hurdle is figuring out how to actually keep it alive.
Because surviving is not the same as thriving.
Exactly. We need to transition into the applied science of cultivating this plant and engineering its ideal environment. This takes us directly into the mechanics of environmental design.
Let's look at where this plant naturally thrives in the wild, because it gives us the blueprint for what we need to recreate at home.
If you're planting it directly into the ground outdoors, it is strictly limited to USDA hardiness zones 9 through 11. Because it's a true tropical specimen, its metabolic sweet spot, the temperature range where it grows fastest and healthiest, is between 70 and 80 degrees Fahrenheit, which translates to roughly 21 to 26 degrees Celsius.
It does possess a very marginal tolerance for cold weather, but we are talking about highly transient, brief dips in temperature. It can technically survive a short-lived drop down to about 19.4 degrees Fahrenheit or -7 Celsius.
However, if you live in an environment that experiences prolonged, deep winter freezes, where the ground itself freezes solid, the cellular structure of the foliage will rupture and the plant will die back entirely to the root system.
In those colder northern zones, attempting to grow it in the ground is a lost cause. You absolutely must cultivate it in a large container so you have the mobility to bring it indoors before the first frost hits.
So whether you are picking a spot in the garden or placing a pot in your living room, we have to talk about setting up the microenvironment, beginning with the delicate, often frustrating balance of light. Outdoors, the horticultural consensus is that it requires a minimum of 6 to 8 hours of direct sunlight to function properly.
But there is a massive paradox built into that requirement.
Let's explain that.
It's the classic paradox of many tropical understory plants. On one hand, they require the massive raw energy output of direct sun to fuel their rapid growth rate and to manufacture the immense energy reserves needed to produce hundreds of heavily perfumed flowers.
They need that solar power.
But on the other hand, their broad green foliage evolved in humid environments and can be surprisingly sensitive to harsh, baking, arid heat. Therefore, the absolute ideal outdoor placement is a location that gets blasted with bright, direct sunlight throughout the morning and early afternoon, but then receives partial dappled shade during the most blistering, intense hours of the late afternoon.
If you expose it to too much intense late day sun, the UV radiation will literally cook the leaves, causing severe scorch and brown, crispy edges.
Conversely, if you put it in deep, full shade to protect it, it simply will not be able to photosynthesize enough energy to fuel the blooming process. It will survive, but it will never flower.
And what if you're trying to replicate that balance indoors as a houseplant? The sun's intensity changes completely once it passes through a pane of glass.
Indoors, the glass filters out a significant portion of the UV spectrum, lowering the overall intensity. The goal indoors is to provide the brightest possible indirect light. You want to position the container directly in front of a south-facing or an east-facing window.
An east-facing window is often considered the gold standard because it captures the gentle, cooler rays of the morning sun, providing energy without the risk of heat stress.
A south-facing window will provide consistent, highly bright light throughout the entire day, which is excellent, provided the plant isn't pressed directly against hot glass during the summer.
Okay, so we have the light dialed in perfectly. Now, we have to look beneath the surface. Let's dig into soil mechanics, because you cannot just take a shovel, dig a hole in dense, heavy clay in your backyard, drop this tropical plant in, and expect it to survive.
It will suffocate. It will fail completely. The Cestrum nocturnum demands an exceptional level of drainage in its root zone.
When we talk about ideal soil texture, we are looking for a loamy or sandy loam composition that has been generously amended with rich organic matter, such as high-quality compost or well-rotted manure.
Chemically, it prefers a soil pH that sits right around the slightly acidic to neutral mark, specifically between 6.0 and 7.5.
I want to break down the why behind that specific dirt recipe. Why does it need that exact physical texture to thrive?
It requires a highly delicate mechanical balancing act beneath the soil. Consider the plant's metabolism. It is a notoriously heavy feeder that pushes out rapid vegetative growth, so the soil matrix needs a high concentration of organic content, that's the compost, to act like a sponge, holding onto essential nutrients and moisture.
But at the same time, the delicate root system of the nightshade family is highly susceptible to an anaerobic condition.
Yes. If the roots sit in stagnant standing water, they are starved of oxygen and will rapidly begin to rot and decay.
By insisting on a loamy or sandy texture, you're ensuring that while the compost holds the food, the larger particles of sand and aggregate create millions of microscopic physical channels through the soil.
These channels allow the excess water from a heavy rainstorm or a deep watering to immediately drain away from the root zone. The roots are bathed in moisture, but they are still able to breathe oxygen.
And if you're cultivating this indoors, you are tasked with artificially recreating that exact mechanical balance within the confined space of a pot.
The horticultural guides strongly recommend starting with a high-quality, porous commercial potting mix, but then heavily modifying it yourself by mixing in generous amounts of orchid bark, coarse perlite, or coconut coir.
You're intentionally building a chunky, aerated soil structure that allows gravity to pull the water out as fast as possible, which provides the perfect transition into the actual art of watering. How do you keep a thirsty tropical plant fully hydrated without accidentally drowning it in its own pot?
The universally accepted gold standard for watering this specific species is the soak and dry methodology. During the active growing season, which encompasses the long, hot months of summer, you will likely find yourself watering the plant 2 to 3 times a week, depending on the heat.
But the technique is crucial. You do not just give it a little splash of water on the surface every day.
No, absolutely not. You must water it thoroughly and deeply, completely saturating the entire root zone until you see water running freely and steadily out of the drainage holes at the bottom of the container.
And then comes the hardest part for most well-intentioned indoor gardeners. You put the watering can down and you walk away.
You step away completely. You must practice severe restraint. You do not apply another drop of water until you can stick your finger into the soil and feel that the top 1 to 2 inches are completely dry to the touch.
This cyclic process of complete saturation followed by a drying period forces the roots to physically grow downward, searching deeper into the pot for the receding moisture layer. This creates a much stronger, more resilient, and expansive root system.
Conversely, in the winter, when the days shorten and the plant's metabolism slows down into a semi-dormant state, you must drastically pull back on your watering frequency. You might only execute a deep soak once every 7 to 10 days, again, strictly waiting for that top layer of soil to dry out completely before intervening.
While reviewing the materials on container gardening, I found a really fascinating mechanical nuance that directly impacts this watering schedule. The physical material that your pot is made of changes the physics of how the soil dries out.
It does.
If you choose to plant your Night Blooming Jasmine in a classic, unglazed terracotta clay pot, you are going to have to water it significantly more often than if you planted it in a plastic or a glazed ceramic container.
That is an incredibly important physical dynamic to understand. Terracotta clay is a naturally porous, highly breathable material. When you water the soil, the clay walls of the pot physically absorb moisture from the dirt.
The water then travels through the clay and evaporates directly into the air from the outside surface of the pot.
The entire container breathes. This physical property is actually a massive advantage because it helps the soil dry out much faster, drastically reducing the risk of root rot.
However, the trade-off is that it demands you be much more vigilant with your watering schedule, as the pot itself is actively wicking moisture away from the plant.
Right. Plastic pots, on the other hand, form an impermeable vapor barrier. They trap 100% of the moisture inside the soil matrix, meaning the dirt stays wet much longer, and your margin for error regarding overwatering is significantly smaller.
So we have the light dialed in, the soil mechanics are perfectly balanced, and the watering technique is flawless. There is one final environmental factor required to truly mimic its Caribbean homeland: ambient humidity.
Yes, this plant evolved to thrive in 50 to 60% relative humidity.
The problem is that the average modern home, especially during the winter when the central heating system is running constantly, is a desert. It is vastly drier than that. How do we artificially inject that moisture back into the air?
You have several highly effective, low-tech hacks at your disposal. The most direct and reliable method is simply purchasing a small, dedicated room humidifier and placing it in the general vicinity of the plant.
If you prefer not to manage another electronic device, you can easily create a localized microclimate by constructing a wet pebble tray. You take a wide, shallow tray or saucer, fill it completely with coarse gravel or river pebbles, and pour water into the tray.
As the ambient room temperature causes that water to evaporate, it creates a constant, invisible column of rising humidity that envelops the foliage of the plant sitting above it.
But there is a critical rule of physics you cannot violate when setting up a pebble tray. Otherwise, you will kill the plant.
Absolute strict adherence is required here. The bottom of your plant pot must sit securely on top of the dry surface of the pebbles, completely elevated above the actual water line in the tray.
If the base of the pot sits physically in the water, the capillary action of the soil will act like a sponge, wicking that standing water straight up through the drainage holes and directly into the root zone.
Your soil will remain permanently saturated, anaerobic conditions will develop, and you will inevitably induce root rot.
Another brilliant, entirely biological hack for raising humidity is to simply group your various houseplants close together. Plants are constantly releasing microscopic water vapor through their leaves in a biological process known as transpiration.
By clustering several plants into a tight grouping, they share that transpired moisture, naturally creating a humid microclimate for the entire collective.
If you follow these protocols, you have now curated this pristine, humid, perfectly draining, optimally lit environment. The plant is responding. It's pushing out massive amounts of glossy green foliage. It looks incredibly healthy. But you're looking at this giant green bush and you realize something is missing. Where are the flowers?
The most anticipated phase of cultivation, the bloom protocol.
We need to dissect the exact pruning, feeding, and troubleshooting steps required to force this plant to perform. Because the entire reason you tolerate its toxic nature is to experience those intensely fragrant night blooms.
And according to the botanical data, with the right precise care, a Cestrum nocturnum is capable of blooming up to 4 distinct times in a single year, typically cycling from late spring all the way through to early fall.
Generating 4 massive flushes of blooms in a single growing season requires a staggering expenditure of biological energy from the plant. It's a monumental physiological feat.
And because it requires so much energy, it's the first process the plant will abandon if conditions are not perfect. It's incredibly common to see desperate posts on botanical forums from gardeners who are immensely frustrated because their massive 4-year-old Night Blooming Jasmine has never produced a single fragrant flower.
It's perfectly green, but completely sterile.
Exactly.
Let's systematically troubleshoot that failure to bloom. If someone has a lush green plant with 0 flowers, what is going wrong?
When any plant stubbornly refuses to transition into its reproductive blooming phase, it is almost universally signaling a severe stress response or a critical resource deficiency. You have to investigate the primary environmental culprits.
The most common limiting factor is insufficient light energy.
If you've placed the plant in too much shade, it may gather enough light to produce green leaves, but it simply cannot photosynthesize the massive surplus of energy required to construct complex floral structures.
The second culprit is environmental temperature. If the ambient temperature consistently drops too low, especially at night, the plant shifts into a defensive survival state, locking itself in a vegetative mode and refusing to expend energy on reproduction.
What role does our watering technique play in this? Can poor watering habits suppress the blooms even if the light and temperature are perfect?
Without a doubt, Improper watering acts as a massive physiological stressor.
If the plant experiences extreme drought stress because you forget to water it, or if it is constantly waterlogged and suffocating in mud, its internal survival mechanisms trigger.
It instantly abandons any attempt at reproduction, aborting bud development entirely, and focuses 100% of its remaining energy reserves on merely keeping its existing root system and foliage alive.
And finally, the fourth major culprit preventing blooms is a severe nutrient deficiency in the soil. If the organic matter in the pot is exhausted, the plant literally lacks the chemical building blocks necessary to assemble a flower.
Which means we need a highly specific fertilization strategy. How do we properly feed the queen of the night to support 4 bloom cycles?
During the active, high metabolism growing season, which stretches from early spring through the end of summer, you need to implement a consistent feeding schedule. Applying a high-quality, balanced liquid fertilizer every 2 to 4 weeks is optimal. A standard 10-10-10 ratio is the baseline recommendation for maintaining overall robust plant health.
I want to briefly pause and translate that 10-10-10 for anyone who might be staring at a wall of bottles in a garden center and wondering what those numbers actually mean. That refers to the NPK ratio, correct? Nitrogen, phosphorus, and potassium.
That is exactly right. It represents the percentage by weight of the 3 primary macronutrients every plant requires. Nitrogen, the first number, is the primary fuel for producing lush, leafy green vegetative growth.
Phosphorus, the middle number, is the biological engine that drives strong root development. And, most crucially for our purposes, it controls reproductive growth, meaning the formation of buds, flowers, and fruits.
Potassium, the final number, acts as a general health booster, supporting cellular integrity, regulating water uptake, and improving overall disease resistance. Applying a balanced 10-10-10 formula provides the plant with an equal, steady diet of all 3 to support massive structural growth.
But the grower notes reveal a major secret here. You do not just passively apply that 10-10-10 all year long and hope for the best. You have to actively change your chemical strategy based on what the plant is doing visually.
The moment you start to see those microscopic, tiny green matchstick buds forming on the stems, you execute a pivot.
This specific chemical pivot is how you practically guarantee a massive explosive bloom.
You must immediately switch your fertilizer to a high phosphorus formula. In the retail market, these are frequently labeled as bloom boosters, and you will notice the middle number in the NPK ratio is significantly higher, perhaps a 10-30-10.
By intentionally flooding the plant's vascular system with a massive surplus of phosphorus at the exact moment it is trying to build flowers, you're handing it the precise chemical tools it needs to maximize the physical size, the sheer quantity, and the aromatic intensity of the blooms.
It makes me think of an athlete carb loading right before a marathon. You are stuffing the system with the exact type of energy it needs for a massive physical exertion.
The biological principle is nearly identical. However, you can provide the plant with perfect direct sunlight, flawless soak-and-dry watering, and a diet rich in high-phosphorus bloom boosters, and your plant still might stubbornly refuse to flower if you ignore the single most important mechanical requirement of its cultivation, the applied science of pruning.
Understanding how to prune the Cestrum nocturnum is absolutely mandatory if you want flowers. It's a non-negotiable step.
And the biological reason behind why you have to cut it is fascinating. It all comes down to the architecture of where the plant is actually capable of producing a bud.
The Night Blooming Jasmine operates under a strict biological rule. It blooms exclusively on new wood.
This means that the fragrant flowers will only ever develop on the soft, fresh, green stems that the plant has actively pushed out during the current growing season.
It will never, under any circumstances, form a flower bud on the older, hardened, woody brown branches from previous years. Therefore, the logic is simple. If you do not aggressively prune the plant to force it to constantly generate new, fresh branches, you will severely limit the physical real estate available for flowers to grow.
So we need to outline the exact timeline and the mechanical technique for this mandatory pruning process. How often are we cutting this plant?
The optimal pruning strategy is divided into 2 distinct phases. First, there is the continuous maintenance phase. You want to perform a light, targeted trim immediately after every single flowering cycle concludes throughout the summer and into the early fall.
This is a process commonly referred to as deadheading.
Mm-hmm.
You take your shears and you snip off the clusters of spent, fading flowers.
By removing them, you intercept the plant's natural reproductive cycle. You stop it from wasting immense amounts of energy attempting to turn those old flowers into toxic seed-bearing berries, and you force it to redirect all of that saved energy back into pushing out another flush of new green foliage.
And then the second phase, the major structural haircut. When does that happen?
The heavy foundational prune must be executed in late winter or very early spring, just before the ambient temperatures rise and the plant wakes up to begin its rapid spring growth phase.
This is your opportunity to dictate the overall shape of the plant, to rein in its massive arching size so it doesn't take over your entire patio, and to physically remove any dead, damaged, or crossing branches that restrict airflow through the center of the shrub.
Let's focus on the actual mechanics of the cut. You cannot just take a pair of hedge clippers and hack away at the outside of the bush like you are trimming a perfectly square topiary.
There is a specific anatomical location on the stem where the cut must be made.
Precision here dictates how the plant responds. You must always make your cut just slightly above a leaf node or a major branch junction.
If you examine the stem, a node is that small, slightly swollen bump where a leaf physically attaches to the branch.
Botanically, that tiny node is incredibly important because it contains dense clusters of dormant, highly volatile cells known as meristematic tissue, which are capable of explosive rapid growth.
When you sever the stem just above that node, you physically remove the dominant growth hormone located at the very tip of the branch, a concept called apical dominance.
The removal of that chemical signal suddenly wakes up the dormant cells in the node below the cut, triggering them to start dividing rapidly, which forces the plant to push out a brand new, vigorous, bushy branch in that exact spot.
And because that brand new branch is technically new wood, that is the exact location where your massive clusters of night blooming flowers will eventually form. You're literally engineering the architecture of the bloom.
Exactly. You are dictating where the plant will flower. However, there is a critical limitation to observe. Even during the most aggressive, heavy, late winter structural prune, you must never remove more than 1/3 of the plant's total biological mass in a single session.
If you cut it back too severely, you will induce a state of profound physiological shock. The plant will panic, its growth will stunt, and it may completely abandon flowering for the entire year as it struggles to rebuild its energy-gathering foliage.
Before anyone even thinks about picking up a tool to make that first cut, we have to address the critical protocol of sanitation. This is a step that I guarantee a huge percentage of casual weekend gardeners skip entirely, and it is responsible for the slow, confusing death of countless plants.
Skipping sterilization is the botanical equivalent of a surgeon refusing to wash their hands before operating on a patient.
Whether you are using small precision hand pruners for the thin green stems, heavy lopping shears for the thicker woody branches, or a serrated pruning saw for major structural cuts, you absolutely must sterilize the metal blades before you make the first cut, and crucially, you should re-sterilize them between moving from one plant to another.
You can achieve this by thoroughly wiping the blades down with high-percentage rubbing alcohol, or by dipping them into a solution of 1 part household bleach to 9 parts water.
If you neglect this step, your pruners act as a mechanical vector. You will take microscopic fungal spores or devastating bacterial infections from a sick plant in your yard and physically inject them directly into the open, weeping vascular system of your freshly pruned, highly vulnerable night blooming jasmine.
Let's assume you follow all the rules. You sterilize your tools, you locate the node, you make the perfect cut. You are now holding these beautiful, healthy, vibrant green clippings in your hand. The biggest mistake you can make at this point is throwing them into the compost bin.
Because this brings us to one of the most exciting aspects of cultivating this species, cloning the queen. The propagation masterclass. You can actually utilize those pruned stems to manufacture an infinite supply of new night blooming jasmines.
It's a profoundly rewarding process. It allows you to rapidly expand your own garden design or to easily share this remarkable, rare botanical experience with your friends and neighbors.
While it is technically possible to grow Cestrum nocturnum from seed harvested from the toxic berries, propagating it asexually from stem cuttings is a vastly superior method.
It's exponentially faster, it has a much higher success rate, and most importantly, it guarantees that the new plant will be a 100% exact genetic clone of your parent plant, preserving its specific vigor and fragrance profile.
So let's break down the step-by-step masterclass on how to clone this plant successfully. Step 1. Acquiring the perfect cutting.
The selection process is key. You want to identify a highly vigorous, actively growing stem consisting entirely of new wood. It should be flexible and green, not stiff and brown.
The ideal length for a viable cutting is between 2 and 5 inches. Using your freshly sterilized pruners, you want to make a clean, sharp cut directly below a leaf node.
Step 2 involves prepping that cutting for the soil. The horticultural instructions state that you must immediately strip away and remove all of the leaves situated on the bottom half of that severed stem.
You're only allowed to leave 2, maybe 3 small leaves at the very apex of the cutting. Visually, you're essentially stripping the stem naked.
Why is that drastic reduction in foliage necessary?
It is entirely a matter of biological energy conservation and critical moisture management. Broad, green leaves require massive, continuous volumes of water to stay turgid and alive. Furthermore, through the process of transpiration we discussed earlier, leaves are constantly sweating out interior moisture into the surrounding air.
The critical problem is that
If you leave all the foliage attached, the cutting will literally sweat itself to death, desiccating completely before it ever has a chance to form new roots. Additionally, by physically removing those lower leaves, you forcefully disrupt the plant's internal hormone balance.
you stop it from expending energy trying to maintain useless foliage, and you redirect 100% of its biological focus into the urgent life-or-death task of pushing out new root cells from the freshly exposed nodes on the buried stem.
It's a forced prioritization of survival.
Step 3 introduces a chemical assist to speed up that survival process. The protocol is to dip the bottom 1 inch of the cut, leafless stem into a commercial rooting hormone.
And the grower notes offer a massive professional-level tip here. Do not just buy any generic rooting powder. Specifically, seek out a rooting hormone that includes a fungicidal compound in its formula.
That specific addition of a fungicide is brilliant because the environmental conditions required to force a cutting to root, high moisture, high humidity, warm soil, are the exact same environmental conditions that act as a perfect incubator for deadly fungal rot.
The fungicide provides a chemical shield while the fragile roots form. However, there is a critical procedural rule regarding how you apply the rooting hormone. You must never take your fresh cutting and dip it directly into the master jar of the hormone powder or gel.
You have to pour a small, isolated amount out onto a separate dish or a saucer, correct?
Absolutely imperative. If your fresh cutting happens to be carrying a single microscopic fungal spore or a bacterial pathogen on its stem, and you plunge it directly into the main container, you have just instantly contaminated your entire supply of rooting hormone.
Every subsequent cutting you dip into that jar will be infected.
Always pour a small mound onto a secondary saucer, dip the moistened end of the cutting, gently tap off the excess powder, and then immediately discard whatever hormone remains on the saucer.
The cutting is prepped, stripped, and chemically treated. Step 4 is the physical planting process. You need to bury the treated end roughly 3 inches deep into the soil.
But again, the mechanical rules apply. You're not using dense potting soil from your garden bed. You must mix a highly specific custom medium consisting of exactly equal parts peat moss and perlite. And the guides suggest putting at least 2 cuttings into every container you prepare.
The composition of that specific soil mix dictates the success of the roots. The peat moss component provides intense, sponge-like moisture retention, ensuring the developing root cells never dry out.
The perlite component, which are those small, white, heat-expanded volcanic glass rocks, ensures massive structural aeration. It physically props the soil open, ensuring the fragile new roots don't suffocate in a dense, muddy environment.
The recommendation to plant 2 cuttings per pot is simply an actuarial insurance policy. Not every cutting survives the trauma.
By planting 2, you mathematically increase the odds that at least 1 will successfully establish a root system, allowing you to avoid the stressful process of digging them up to consolidate empty pots later.
Now we arrive at step 5. This is undeniably my favorite part of the entire propagation masterclass because it is a brilliantly effective, incredibly low-tech DIY hack designed to engineer the perfect atmospheric environment for rooting.
You take a standard clear plastic juice jug or an empty milk gallon, you use scissors to cut the bottom completely off, and you simply place the top half of the jug right over the pot, enclosing the cutting like a transparent dome.
It functions as a remarkably efficient, zero-cost miniature greenhouse. We established that the stem cuttings desperately require high ambient humidity so the 2 remaining top leaves don't dry out and die while the subterranean roots are slowly forming.
That plastic jug physically traps the moisture evaporating from the damp peat moss, creating a localized, perfectly humid microclimate that surrounds the cutting in a protective vapor barrier.
So your miniature dome is set up. You ensure the peat mixture stays consistently moist, and critically, you keep the entire apparatus completely out of direct, baking sunlight so you do not accidentally cook the fragile cuttings inside the plastic greenhouse. And then you simply wait. What is the biological timeline for this process?
Patience is the final ingredient. The biological transformation takes approximately 8 weeks to complete. You will know that the subterranean roots have successfully formed and established a functional vascular system when you observe fresh, new, bright green leaves actively emerging from the top nodes of the cutting.
Once that new vegetative growth appears, you have successfully engineered a brand new, genetically identical, independent Night Blooming Jasmine. It is now ready to be carefully repotted into a larger container and eventually acclimated for life outdoors.
Which is an incredible, highly rewarding achievement. You've literally forced life from a severed branch. But now that you possess these precious, vulnerable plants, your role shifts from cultivator to defender.
The reality is that an outdoor environment is a hostile place, and a lush, fragrant, fast-growing tropical plant acts like a beacon for opportunistic invaders. This brings us to Section 6, Defense and Winter Survival. Let's start by identifying the primary threats, the pests.
It's a fascinating biological irony that despite its profound toxicity to mammals, the Cestrum nocturnum remains highly vulnerable to a specific, specialized array of insect pests that have evolved chemical workarounds to safely feed on its sap and foliage.
If you're growing this plant, the most common invaders you will battle are aphids, various caterpillars, the giant whitefly, spider mites, and scale insects. Let's break down the diagnostic symptoms for each and the specific protocols for fighting back.
Aphids are incredibly common. They are tiny, pear-shaped, soft-bodied insects that almost always congregate in dense clusters on the absolute newest, most tender, light green tip growth. They plunge their mouthparts into the plant and suck the nutrient-rich sap.
Visually, you'll know you have an aphid problem because the new leaves will start to physically distort, curling up tightly and turning a sickly pale yellow.
The most effective initial treatment for an aphid infestation is remarkably low-tech and entirely physical. Before you even consider reaching for heavy chemical pesticides, simply attach a spray nozzle to your garden hose and hit the infested foliage with a firm, highly targeted, sharp blast of water.
The mechanical force physically knocks the aphids off the plant. Because their bodies are soft and their mouthparts are deeply embedded, the force of the water often fatally damages them, or at the very least, prevents them from ever climbing back up the stem.
The next invader on the hit list is caterpillars. The diagnostic symptom here is glaringly obvious. You will see large, ragged, asymmetric chunks missing from the edges of the leaves, or massive holes chewed directly through the center of the foliage. The treatment protocol: pure manual labor. Pick them off by hand and relocate them far, far away from your patio.
Then we escalate to the more insidious, difficult-to-spot pests, spider mites and scale insects. Spider mites are arachnids, nearly microscopic to the naked eye.
The visual clue they leave behind is a distinct stippling effect. Thousands of tiny pinprick yellow blotches across the surface of the leaves, often accompanied by a very fine, dense webbing spun tightly between the stems and leaves.
Scale insects are bizarre. They look less like bugs and more like small, raised brown or waxy armored bumps permanently glued to the stems and the undersides of leaves. Both are relentless sap suckers that will slowly drain the vitality from the plant.
For these heavily armored or protected pests, you must step up your defensive measures. The application of horticultural oils, particularly high-quality neem oil or specialized insecticidal soaps, is highly effective.
These treatments work mechanically, not chemically. The thick oil coats the exterior of the pests and physically suffocates them by blocking their breathing pores, entirely avoiding the use of toxic, broad-spectrum chemical residues that might harm beneficial pollinators in your garden.
But the pest that the research notes highlight with flashing red warning lights is the giant whitefly. Not just because they are incredibly visually annoying. When you brush against the plant, they flutter up in a chaotic cloud that looks like flying white dandruff, but because they represent the beginning of a devastating biological pipeline that leads directly to a systemic disease.
If we trace the ecological dots between insect pests and fungal disease, the whitefly acts as the primary vector. As the massive colonies of whiteflies, and similarly dense populations of aphids, aggressively feed on the vascular sap of the plant, Their bodies process the nutrients and excrete a highly concentrated, sticky, sugary waste product known scientifically as honeydew.
This viscous liquid drips down and heavily coats the surface of the leaves situated below the feeding colony.
It essentially covers the lower half of your plant in a layer of bug syrup.
That is a highly accurate description. And when you combine a thick layer of sticky, sugary syrup with the high ambient humidity that the Cestrum nocturnum requires, you create the absolute perfect, nutrient-rich culture medium for an aggressive fungal infection known as sooty mold.
The visual manifestation of this disease looks exactly like its name implies, a dark, dense, black, powdery mold that rapidly spreads to completely cover the upper surface of the affected leaves.
And while I understand that the black mold itself is not acting like a parasite,
Yeah.
it isn't physically eating the leaf tissue or injecting toxins, its presence is still lethal to the plant, correct, because it acts as a physical barrier.
Exactly. The density of the black mold forms an opaque physical shield over the leaf's epidermis. It completely blocks out sunlight, instantly shutting down the plant's ability to photosynthesize in those areas.
The affected leaves can no longer produce the carbohydrates required for survival, and the plant's overall health rapidly and visibly declines.
The crucial insight for treating sooty mold is realizing that you do not actually treat the mold itself. Applying a fungicide to the black powder is useless. You must break the pipeline at the source by eliminating the whiteflies or aphids that are manufacturing the honeydew.
Once you eradicate the pest population using a targeted spray of mild dish soap and water or neem oil, the continuous rain of honeydew stops. Deprived of its sugary food source, the black mold will eventually dry up, flake off, or it can be very gently wiped away with a damp, soft cloth to restore the leaf's ability to gather light.
Beyond the whitefly pipeline, the diagnostic guides highlight two other major diseases that cultivators must actively monitor. The first is a vascular infection called Fusarium wilt.
The documentation states that this pathogen causes the sudden appearance of dark necrotic spots, large discolored patches spreading rapidly across the foliage, and severe irreversible wilting of entire branches.
The recommended intervention is immediately applying a targeted baking soda spray solution or escalating to a commercial broad-spectrum fungicide to halt the spread. But the second major disease is one we have already touched on, and it is arguably the most common cause of death: root rot.
Root rot is a tragedy because it is almost entirely a human-caused mechanical disease. It is the direct, unavoidable consequence of chronic overwatering combined with inadequate soil drainage.
If the root system is forced to sit submerged in a saturated, airless anaerobic mud, the root cells literally drown, die, and rapidly begin to physically decay and turn to mush.
The profound irony is how the visible symptom manifests above ground. Because the rotted roots can no longer absorb water, the plant rapidly wilts, droops, and the leaves turn pale yellow.
Which creates an incredibly confusing fatal trap for the gardener. The plant visually looks like it is dying of thirst, so the natural human reaction is to aggressively water it more, which just accelerates the drowning process and kills the plant even faster.
It is a vicious, tragic cycle of misdiagnosis. If your plant is severely wilting but you know the soil is heavy and wet, you must immediately suspect root rot. To confirm it, you have to physically pull the plant completely out of its container and inspect the root ball.
A healthy, functional root system will be firm to the touch and typically stark white or light tan in color. Rotted roots are visually striking. They are dark, slimy brown, completely mushy, and they will emit a distinct, foul, swampy odor of organic decay.
If you catch the infection in its early stages, you can attempt to salvage the organism by using sterilized shears to meticulously trim away all of the mushy, decaying roots. You then treat the remaining healthy root mass with a safe copper-based fungicidal spray to kill lingering spores.
And critically, you repot the plant in entirely fresh, completely dry, highly porous soil, strictly adhering to the soak and dry watering method going forward.
So assuming you have successfully navigated this gauntlet, you have battled the insect pests, you have conquered the threat of rot, you have pruned it perfectly, and your night blooming jasmine has thrived and bloomed profusely all summer long.
But inevitably, the seasons turn. The days grow noticeably shorter. The evening air develops a crisp chill. Winter is approaching, and as we definitively established, this tropical queen of the night is profoundly frost-tender.
If left outside to face a freezing night, its cellular structure will collapse and it will die. We have to discuss the critical logistics of overwintering and the highly stressful process of transitioning the plant indoors.
We cannot overstate how traumatic this transition is for the organism. You are violently shifting it from a dynamic, highly ventilated, humid outdoor environment into the static, incredibly dry, artificially heated environment of a human living space. Meticulous preparation is the key to its survival.
And the absolute first non-negotiable step of that preparation. You do not, under any circumstances, bring the outdoor insect ecosystem inside your house.
That is a recipe for an indoor infestation. Exactly 1 week before you intend to move the heavy pot across your threshold, you must subject the plant to a rigorous microscopic inspection and a literal physical bath.
You take a damp, soft cloth, and you meticulously, painstakingly wipe down both the umber surface and the underside of every single leaf on the plant. This mechanical action physically removes and crushes any lingering aphids, hidden spider mites, or dormant whitefly eggs.
If you skip this step, those hidden pests will be carried into the warm, perfectly climate-controlled, predator-free environment of your living room, and their population will explode exponentially, overwhelming the plant while it is stressed.
The horticultural transition guides also strongly suggest executing a light structural pruning right before the big move. This isn't the heavy spring cut, but just enough to reduce its massive sprawling size so it fits into a compact, manageable shape and isn't physically dominating half of your living room.
So the plant is clean, it's trimmed, and you bring it inside. Where is the optimal placement for survival?
The goal now is to safely induce and support a state of semi-dormancy or hibernation. You must place the container in close proximity to that bright south-facing or east-facing window we discussed, maximizing whatever weak winter light is available.
However, you must be hypervigilant about the microclimate around that window. Ensure the plant is placed far away from any cold, freezing drafts leaking in from doors or poorly sealed window panes, and simultaneously keep it far, far away from the dry, blasting, intense heat of a radiator or a forced air heating vent.
Rapidly fluctuating temperature extremes will induce severe physiological stress and cause the plant to drop all of its leaves in a panic response.
And during this extended indoor winter period, you have to actively suppress your instinct to care for it. You change your routine completely. You drastically stretch out the watering schedule, adhering strictly to the extreme end of the soak and dry method, and most importantly, you absolutely do not apply any fertilizer.
Correct. Applying nitrogen or phosphorus during the winter is a grave mistake. You do not want to artificially stimulate the plant to push out new, highly tender, vulnerable green growth when the ambient light levels are so critically low and the organism is desperately trying to rest and conserve its energy. You must simply let it sleep.
And then finally, the earth tilts back. Spring arrives. The danger of the last frost has officially passed. The temperature stabilizes. It is time to bring the queen out of hibernation and return her to her outdoor patio kingdom.
But the absolute worst thing you can do at this moment is simply pick up the pot, carry it outside, and drop it in the full blazing sun on the first nice day of May.
Doing so is a guaranteed, highly efficient way to cause catastrophic, fatal sunburn to the entire organism. You have to consider the plant's biology. It has spent the last 4 or 5 months slowly adapting its cellular structure to survive on the heavily filtered, incredibly low-intensity light of your indoor environment.
To maximize light capture, the plant has actively thinned out the protective waxy cuticle on its leaves, making them wider, thinner, and highly sensitive.
If you take those delicate, adapted leaves and violently thrust them directly into the full, unfiltered, intense UV radiation of the spring sun, the UV rays will literally scorch, bleach, and destroy the cellular tissue in a matter of hours. The lush green foliage will turn a sickly, crispy white and die off completely.
The solution to preventing that trauma is a very specific, deliberate horticultural process called hardening off.
It is an exercise in extreme patience. Over the course of 1 to 2 full weeks, you must slowly and incrementally reintroduce the plant to the harsh outdoor elements.
You begin on day 1 by placing the container outside in deep, fully protected shade for just 2 or 3 hours in the morning, and then you bring it right back inside the house.
Over the following days, you gradually, methodically increase the total number of hours it spends outdoors, and you slowly migrate the pot into areas that receive gentle, dappled sunlight and eventually direct morning sun.
By the conclusion of the second week, this gradual exposure will have triggered the plant to physically thicken its leaf cuticles, its cellular structure will have successfully toughened up to withstand UV radiation, and it will be fully acclimated to its permanent summer position.
It is finally ready to tap into the massive energy of the sun and begin the incredible, demanding cycle of rapid growth and heavily perfumed blooming all over again.
Looking back at everything we have covered, let's take a deep breath and recap the incredible complexity of this botanical journey. We set out to provide the definitive masterclass on cultivating the night blooming jasmine, the Cestrum nocturnum.
We discovered that this organism is the ultimate master of disguise, masquerading as a completely unassuming, visually basic green shrub during the daylight hours, only to undergo a dramatic clockwork transformation into an intoxicating, mosquito-repelling powerhouse of intense tropical perfume the moment the sun sets.
We meticulously unpacked its hidden botanical reality, confronting the fact that it is a prominent member of the highly toxic Solanaceae family. We established the strict management protocols required to handle its toxic leaves and the dangerous white berries, particularly highlighting the acute risks to domestic pets and children.
We also built a comprehensive roadmap for navigating the treacherous, often misleading jasmine roulette of common names encountered at the retail nursery, separating the safe, true jasmines from the highly dangerous imposters like the Carolina jasmine.
We engineered the absolute perfect environmental blueprint for its survival, recognizing its strict adherence to USDA zones 9 through 11, calculating the highly specific paradoxical balance of intense morning sun and protective afternoon shade, designing the exact loamy, porous soil mechanics required for rapid water drainage, and instilling the strict, disciplined practice of the soak and dry watering methodology.
We completely decoded the complex, energy-intensive bloom protocol. We established that precise, aggressive pruning specifically on new wood, combined with the strategic, timely application of high-phosphorus bloom-boosting fertilizers, are the mechanical keys to unlocking its incredible capability to produce 4 distinct floral displays a year.
We also provided a step-by-step masterclass on the exact science of asexual propagation, utilizing the DIY plastic jug greenhouse hack to successfully clone the plant from stem cuttings.
And finally, we detailed the active defense strategies required to protect it against the insidious whitefly pipeline that leads directly to suffocating sooty mold, the dangers of mechanical root rot, and the immense patience required to safely guide the plant through the highly traumatic transitions of winter indoor hibernation and the critical spring process of hardening off.
It undeniably demands an extraordinary, meticulous level of care and attention, but the ultimate reward is experiencing that unbelievable, invisible, 300-foot wave of sweet tropical perfume washing over your patio on a warm summer night.
When you invest that much specific, tailored effort into understanding and supporting the biology of an organism, it ceases to be just a decoration. It becomes a profound interactive relationship you build with a highly complex living thing.
It truly does. And before we officially conclude our masterclass today, there is one final, larger philosophical concept regarding this plant's behavior that I want to leave you with. Something for you to ponder the next time you step outside at night.
Think deeply about the grand biological strategy that the night blooming jasmine has employed to survive. In the incredibly harsh, hyper-competitive, chaotic world of biological survival and reproduction, this specific nightshade looked at the frantic daytime rat race. The millions of brightly colored flowers desperately screaming for the fleeting attention of bees and birds under the scorching heat of the sun, and it completely intentionally opted out.
It recognized, on an evolutionary timescale, that the traditional game was rigged with far too much overwhelming competition.
By shifting its entire biological clock, its physical flower structure, and its massive chemical energy output to the night shift, it entirely bypasses the chaotic noise and competition of the day. It carves out a highly specialized, incredibly exclusive, VIP-only symbiotic relationship with moths and bats under the quiet of the moonlight.
It achieved massive biological success, not by fighting harder and shouting louder in the crowded daytime arena, but by finding its own uncontested niche and completely owning the quiet hours.
And observing that strategy forces us to ask a much larger question. What other vibrant, incredibly complex ecosystems and hidden biological night shifts are occurring right now in our own backyards, or perhaps even in the structure of our own daily lives, while we are completely asleep, utterly blind to a whole different, highly efficient world of strategy and survival?
It serves as a beautiful, fragrant reminder that there is always vastly more complexity and life occurring in the dark than we ever realize.
It absolutely does. Thank you so much for joining us on this incredibly deep dive into the fascinating, intoxicating, and admittedly slightly dangerous world of the night blooming jasmine. Now that you have the knowledge, go double-check those scientific Latin tags, respect the inherent power of the nightshade, and get your hands dirty. We will see you next time.